Let us look at the nature of standard sequence n to the power of 1 by n. So this would be 1 to the power of 1 by 1, 2 to the power of 1 by 2, 3 to the power of 1 by 3, and so on. And remember, this is nothing but the root of n. So here we have first root of 1, second root of 2, third root of 3, fourth root of 4, and so on. We can say n to the power of 1 by n is equal to 1 plus p, since n to the power of 1 by n is greater than or equal to 1, which implies p is non-negative. Taking both sides to the power of n, we get n is equal to 1 plus p to the power of n. What we are going to do is figure out the upper bound for p. Lower bound we already know is 0. So we use the binomial theorem to expand 1 plus p to the power of n. So 1 plus n times 1 times p plus n times n minus 1 by 2 factorial, and so on. Simplifying this, we get 1 plus np plus p square times n minus 1 by 2, and so on. Since all the terms in the RHS are non-negative, how can we say that? Because here we have only n and p. N is in natural numbers and p is non-negative. That means all the terms in this expansion are going to be positive. So removing some terms reduces the sum. Now let's try out some possibilities. If we remove all but the first term, what do we get? We get 1 plus p to the power of n is equal to 1. But since we are dropping everything else, it becomes actually greater than or equal to 1. Now let's solve for p. Taking the nth root, we get 1 plus p is greater than or equal to 1, which means p is greater than or equal to 0, which we already know. So this doesn't really help us. So let's take the first two terms. We remove all but the first two terms. What do we have? 1 plus p to the power of n is equal to 1 plus np. Now let's again solve it for p. We get n is greater than or equal to 1 plus np, which implies p is less than or equal to n minus 1 by n, which in turn implies that 0 is less than or equal to p, which is less than or equal to n minus 1 by n, which is less than 1. So again, it just provides us a range of values, that is from 0 to 1, in which p can. So again, nothing about convergence of p as n goes to infinity. So this was not very helpful. Now let's take the first term and the third term, because as we have seen, the second term really doesn't help, but we carry the first term because we want to figure out how p behaves starting from 1. Now let's exchange the left hand side and right hand side. The inequality changes. We get 1 plus p square times n minus 1 by 2 is less than or equal to 1 plus p to the power of n. Now 1 plus p to the power of n is n. Where is it? N is equal to 1 plus p to the power of n. So we substitute this with n. Then 1, we bring it to this side. So we get p square times n minus 1 by 2 is less than or equal to n minus 1. P square is less than or equal to 2 goes up 2 times n minus 1. N times n minus 1 comes down here. N minus 1, we can cancel it only if n is greater than or equal to 2 to avoid 0 by 0. So p square is less than or equal to 2 by n, or p is less than or equal to square root of 2 by n. So now we have got some specific upper bound which depends on n. Now, since we already know p is greater than or equal to 0, and now we have reached p is less than or equal to root 2 by n, we can conclude that p lies between them. Now, since p is between them for all n greater than or equal to 2, and since as n goes to infinity, square root of 2 by n goes to 0. So it follows that limit as n goes to infinity of p is equal to 0. So basically 0 remains fixed, and as n keeps becoming bigger and bigger, it comes closer and closer to 0. So limit as n goes to infinity of n to the power of 1 by n is equal to limit as n goes to infinity of 1 plus p. Taking the limit of 1, it's a constant, so it remains 1. And limit as n goes to infinity of n to the power of 1 by n is equal to 1 plus this goes to 0, which gives us 1. So what does this tell us? It tells us that the 1000th root of 1000 is closer to 1 than 500th root of 500. This happens because as n goes to infinity, p goes to 0, which ensures n to the power of 1 by n goes to 1. So bigger the n, closer n to the power of 1 by n is to 1. Remember why we call them as standard sequence? Because they are very useful in non-standard sequences. Okay, so that was nature of standard sequence n to the power of 1 by n. Now, if you found this session helpful, please do like, share, and subscribe. Comment suggestions are always welcome. Thanks for watching. See you in the next session. That's it for now.